In the vast, untamed wilderness of the open ocean, something impossible just happened. The ocean, a force of nature we think we understand, just broke its own record, and the result is terrifyingly beautiful. For a fleeting moment, a single monstrous wall of water rose from the depths, dwarfing everything around it. This wasn't just a big wave, it was a statistical anomaly, a ghost that sailors have whispered about for centuries, now captured and confirmed by science. This was the largest significant wave height ever reliably measured, an instant where the fundamental forces of our planet, gravity, wind, and the chaotic energy of the sea, teamed up to make history. It's a stark reminder that even in the 21st century there are giants still sleeping in the deep. So what exactly happened out there in the lonely expanse of the North Atlantic? The date was November 9th, 2020. A ferocious low-pressure system, a weather bomb, was exploding across the ocean. Winds were screaming at over 80 kilometers per hour, churning the sea into a state of extreme agitation. In this maelstrom, hundreds of miles from any coastline, a lone marine buoy, designated EP-05, was fighting for its life. This unassuming piece of scientific equipment was about to become the sole witness to an event that would rewrite our understanding of the ocean's power. For hours, it recorded wave after wave, each one a mountain of water. But then, something changed. The conditions were perfect for a phenomenon known as constructive interference. Multiple wave trains, generated by the sprawling storm and traveling at different speeds and angles, began to align. Their energies, instead of canceling each other out, started to combine, to stack, feeding into one another. The sea was priming itself for something extraordinary. Measuring a rogue wave is an immense challenge. They are by definition rare and unpredictable. But this time, we were ready. The EP-05 buoy wasn't just a simple float, it was a sophisticated floating laboratory. Packed with accelerometers and GPS sensors, it measured its own vertical displacement with incredible precision. As the monster wave approached, the buoy was lifted skyward, then plunged into the abyss of the preceding trough. It recorded a staggering vertical change of 17.6 meters, or 58 feet. This measurement, known as the significant wave height, represents the average of the highest third of waves in a given period. It was a new world record for a buoy measurement. But the buoy's data was just one piece of the puzzle. High above, satellites like the European Space Agency's Sentinel-1 were also watching. Using advanced radar altimetry, these eyes in the sky scan vast swaths of the ocean, measuring sea surface height. When researchers cross-referenced the buoy's incredible reading with the satellite data from the same time and location, they found a perfect match. The satellite confirmed the extreme sea state. This dual verification, from the surface and from space, gave the measurement an unprecedented level of certainty. It wasn't an instrument glitch, it was real. So how does the ocean conjure such a beast? It's a complex dance between three main partners: wind, resonance, and focus. First, the wind. Sustained high-velocity wind blowing over a long stretch of water, known as the fetch, continuously transfers energy into the sea. The longer and stronger the wind blows, the more energy the waves absorb, growing taller, longer, and faster. But it's not just a simple transfer. A crucial phenomenon occurs when the wind speed matches the speed of the waves themselves. This creates a feedback loop, a resonance, where the wind can push on the back of the wave crests much more efficiently, like a child being pushed on a swing at the perfect moment. This allows the wave to grow exponentially. Finally, and most critically for rogue waves, is the principle of focusing, or constructive interference. Imagine the chaotic surface of a storm-tossed sea not as one set of waves, but as dozens of different wave systems, all with unique sizes and directions. When the crests of these separate systems happen to align at a single point in space and time, their individual heights add together, creating one freakishly large wave that can be more than double the size of its neighbors. This is the ocean's version of a perfect storm. While this 2020 wave set a new instrument record, the title of the highest wave ever belongs to a 1933 account from the USS Ramapo. In the Pacific Ocean, the crew measured a behemoth of 34 meters, or 112 feet, using the ship's own structure as a reference. For decades, tales like these were dismissed as maritime myths. The scientific community's skepticism was shattered on New Year's Day, 1995. A laser sensor on the Draupner gas platform in the North Sea recorded a single massive wave with a crest height of 25.6 meters, or 84 feet, rising from a sea of much smaller waves. The Draupner wave was the first confirmed rogue wave, proving they were not just sailors' yarns, but a real and dangerous threat. Understanding these ocean giants is a quest that takes scientists from the storm-tossed ocean to the controlled environment of the laboratory. Here, in massive wave tanks and flumes, researchers can recreate the complex conditions of the open sea. They can manipulate wind, currents, and wave patterns with precision, allowing them to generate and study miniature rogue waves up close. Alongside physical experiments, supercomputers run complex simulations, modeling the ocean on a global scale. These numerical models can simulate the life of a wave from its birth in a distant storm to its final, powerful convergence. By inputting real-world data from satellites and buoys, scientists can rerun past events, like the 2020 record breaker, to understand the precise sequence of events that led to its formation. This digital forensics is key to unlocking the secrets of wave generation. Ultimately, nothing replaces direct observation. Oceanographers and marine engineers brave the elements on research vessels, deploying an arsenal of advanced sensors into the heart of storms. This fieldwork is dangerous and expensive, but it provides the ground truth data that validates the lab work and computer models, ensuring our understanding of the ocean is firmly anchored in reality. The impact of these extreme waves is profound. For the global shipping industry, a rogue wave is a worst-case scenario. A wave of this magnitude can exert forces far beyond what a vessel is designed to withstand, leading to catastrophic structural failure. Hundreds of ships have been lost over the decades, with rogue waves now considered a primary suspect in many unexplained disappearances. For a select group of elite big-wave surfers, these giants are not a threat, but the ultimate challenge. They actively seek out the world's largest swells, but even they are humbled by the unpredictable nature of rogue waves, which are far more dangerous than the already massive but more predictable waves they typically ride. And as our climate changes, the threat may be growing. Some studies suggest that increasing storm intensity and changing wind patterns could make extreme wave events more frequent. This has dire implications not just for those at sea, but for coastal communities, infrastructure, and ecosystems already vulnerable to a more energetic ocean. Fortunately, our ability to predict and avoid these dangers is improving dramatically. Advanced forecasting models, powered by real-time data from the global network of buoys and satellites, can now provide several days' warning of extreme sea states. For shipping companies, this information is invaluable, allowing them to reroute vessels to avoid the most dangerous zones, saving lives and cargo. This technology is also becoming accessible to everyone. Recreational boaters, fishermen, and surfers can now access sophisticated marine forecasts on their phones, receiving alerts for high surf and dangerous conditions. This democratization of data is a powerful tool for safety, empowering individuals to make informed decisions before heading out on the water. The topic of rogue waves is steeped in myth. One common misconception is that they are a type of tsunami. This is false. Tsunamis are caused by geological displacement like earthquakes and have extremely long wavelengths. Rogue waves are surface phenomena generated by wind and wave interactions. Another myth is that they are a wall of water that appears from a calm sea. In reality, they form within already violent and stormy seas, making them stand out by being exceptionally larger than their chaotic neighbors. The scientific definition itself helps bust some myths. A wave is officially classified as rogue if its height is more than double the significant wave height of the area. So, in a sea with an average of 3-meter waves, a 7-meter wave would be considered rogue. They are not always 100-foot monsters, but rather statistical outliers defined by their relationship to the sea around them. The discovery and measurement of this record-breaking wave is more than just a new entry in a record book. It's a profound reminder that our planet is a dynamic and powerful system with secrets it is still revealing. The ocean, which covers more than 70% of our world, remains one of the last great frontiers of exploration. It shows us that the ocean is powerful, unpredictable, and deeply awe-inspiring. As we continue to push the boundaries of science and exploration, we must do so with a sense of humility and respect for the forces we are studying. So stay curious, ask questions, and never lose your wonder for the natural world. But above all, stay safe, and always, always respect the sea.